All right, let me get your attention for a few minutes. We'll talk a little bit about activity 7, make sure everyone's doing it right. So in activity 7, we are given some information about the drive-through times. Guys, can we, for a second? The drive-through times of McDonald's and In-N-Out. So that's what this means. One customer went through their In-N-Out at went through their drive-through at McDonald's, and it took them 256 seconds to get their food. Another customer went through an In-N-Out, and it took them 428 seconds to get their food. Right, so this is just random information about a few customers that went through each of them. And we want to be able to organize this information so that we can judge and be able to make informed decisions about the average length of time or the mean, or which one's a better choice, which one's doing a better job. So first of all, they asked us to create histograms for these using our calculators. So to do that, let's go to our calculator. You need to type in all the information from the times for In-N-Out and the times for McDonald's. I typed them into here for the McDonald's stuff. So I made list 1 the McDonald's stuff and list 2 the In-N-Out information. So I'm going to work with each one of them at a time. To create the histogram for the McDonald's stuff, which is on list number 1, the first thing you have to do is go over to y equals, make sure that there aren't any problems there. So go to y equals, make sure there's no, see I have some equations right there? It's going to cause an issue. So either delete it, clear it, or you can go to y equals, go to the equal sign, hit enter, and it'll deactivate it so it doesn't cause any problems. Right now I can see that all my plots are deactivated up here. Remember, a shortcut is to highlight them and then hit enter and it'll turn them on, or it'll turn them off. Hit enter, and it'll turn it off. So I want, this is fine, I want them all to be off because I only want one of them to be on, and I'm going to go turn it on myself. So I'm going to hit second, stat plot. From here I get a little overview, and I can also see that they're all off. I'm going to go into the first one, turn it on. I'm going to select histogram, so that's this choice there. Hit enter. And now remember, there were 2 options for creating a histogram. One of them came from grouped data. If it was a grouped data that gave you like the classes, so you came up with like the class midpoint and then the frequency, so you had class midpoint and frequency, then you would write down that information here. List 1, the first list would be where all the class midpoints are located, and list 2, or the other list you put on here, would be the frequencies. This is for grouped data. But right now we don't have group data. They just gave us a list of values for McDonald's that we want to graph. So there has to be a 1 here. Now see how the A is blinking? That's been a mistake for a lot of people. That means that the alpha button is active right now. So if I hit 1 right now, it won't write down 1, it's going to write down Y, because Y is the green button there. So you got to go over to the left here, make sure the alpha button is deactivated, and then I click 1, and then it'll write down a 1. Okay? So now I'm going to go over to Window and type in the values that are given to you there. So we want to start from x minimum of 0 to an x maximum of 600. A scale of 50, x scale of 50, multiples of 50. Each box is going to have a width of 50. Then y minimum of 0 and a y maximum of 5. And y scale of 1. Leave x resolution as 1. It shouldn't affect us at all. When we're ready, we can hit graph, and there it is. So here's a histogram of the McDonald's information. I know that the x-axis will run from 0 all the way out to 600 in multiples of 50. So from 0 to 50 is that first little space there. From 50 to 100 is the second space. Then 100 to 150, 150 to 200, 200 to 250, and so on and so forth. And then on the y-axis is how many values fell inside that little range. So I can tell there was only 1 value between 100 and 150. There were 2 values between 150 and 200, and so on and so forth. Okay, so you can use this to draw it onto your paper and then write down the appropriate values that fall inside the horizontal axis, and the label and title in scale the horizontal axis and the vertical axis. Any questions on that? No? Okay, so do the same thing for the In-N-Out one and draw them in. Okay, so now let's go back to our equation. So hopefully you were able to get all these histograms, you drew them in there. Now let's find standard deviations. Okay, so the equation that is given is this one. However, there are a few variations. There's a couple of equations given to you in your book, so let's take a look at those. Okay, the book provides two different equations. One of them is this one up here, and then the one we're working with right now is this one right here. So what is the difference? As the title here implies, this is the equation we use when we're working with a population, and this is the equation we use when we're working with a sample. Both equations are almost identical, except that in this case, when we're working with a population, we divide by n, the total number of values in our population. Whereas with a sample, if we know we're working with a sample from a population, then we need to divide this by n minus 1. In our case, there were 13 values, so we divide by 13 minus 1. We divide by 13 minus 1, which is equal to 12. Okay. Now, these two other equations here, these equations were popular back before we had computers and calculators, and you had to do a lot of calculations by hand, and these equations actually made it easier and faster to get to your final answer. So to go from here to here, there's some awesome algebra that can take place to make this equivalent to that. And same thing in this case, we can use some algebra, take out our algebra skills and make this equal to this. And then you'll find that when you're working with a large set of numbers, finding the standard deviation with this formula or this formula is actually easier. However, for us in this classroom, we won't do that. If we're doing something by hand, it'll be with a small number of values, and then we will use this formula or this formula. And if we're working with our large number of values, then our shortcut will just be to use our calculator. So now let's see how our calculator can help us do this faster by using row operations. So the first thing we have to do is find the mean of this data. I already put all those numbers into my calculator. They're on list number 1 for McDonald's. Here they are. So if I go over and do a one variable statistics on list 1, I can easily find the mean. So stat, calculate, one variable statistics, L1. So I can see that the mean is 252.6924. Let's just stick to one decimal place because there's going to be a lot of, it's not as accurate, but just because we're going to do a lot of calculations, I think you'll prove your point with one decimal place. So let's make it 252.7. So over here, we need to find out what is the value of each one of these numbers when we subtract 252.7. So we can go to our calculator, go to stat, edit, and we're going to do a row calculation. So I'm going to go to L3, and I'm going to tell it do L1 minus 252.7. Enter, and it automatically subtracts 252 from each one of those numbers. So now I can just go and copy this onto my list. Hang on, I'm almost done, guys. So that's all of these numbers belong right in here. Okay, let me go over there. So, stop it, Microsoft. So right in here, the number is 84.3, and then right in here, it's negative 24.7, and so on and so forth. So I just have to copy them down. Now, guys, almost done. Can I get your attention? Now I need to square each one of those. That's the next column over here. I need to square them. So I can go back to my calculator. I know that this is L3, so I'm going to go to L4. I'm going to clear what's in L4, clear enter, and now go back to L4, and I'm going to do a little equation here. So I'm going to do L3 to the power of 2. Squaring it. Enter, and it squared all of them. So now I can just copy those numbers right in here. This one is 7106.5. Oops. 0.5. And so on and so forth. This one is 610.09. So on and so forth, right? So we can fill out that table pretty quickly now. Finally, we're gonna need to add this list out here. This column needs to be added, and so does this one. So, well, this one has already been added. There are 13 entries in there. So now we need to sum L4. So I can do a one variable statistics on it. Stat, calculate, and it was L4, enter. And then the sum is right here. One of the things it gives me is the sum. So I know that the sum of the whole thing is 40,720.78. Okay? So now that I have that, I can very easily punch it into this equation down here. It's going to be equal to the division of 40,720.78 divided by n minus 1, which is going to be 13 minus 1, or 12. So divide that number by 12. When you get an answer, take the square root of it, and that'll be the standard deviation. Okay? One more thing. Once you do all that work, then you can double check your work, because your calculator just gives you the standard deviation, which is right here. S. S sub x is the standard deviation. So you should be able to get that when you do a one variable statistics on the original list. This is not the answer, because this was a one variable statistics on the list of the values that were being squared. So I got to go back to L1, I believe. So let me look at my edit this guy. My original list was over here, so I need to do a one variable statistics on L1. Here's the McDonald's information. So stat, calculate, one variable statistics, L1, enter. Now your calculator doesn't know whether you're working with a population or a standard deviation or a sample, so it gives you both. This sigma notation is the answer you would get if this was a population and you divided it by 13, n, right? And this is the standard deviation you would get if you divided it by n minus 1, or 12 in our case. So the answer you should be getting there is something pretty close to 63.1313. Keep in mind there's some rounding that happens, so it might be a little bit off because of that reason. Okay? Good? Questions, comments, issues? Awesome.